this is your instructor, Mrs. Thompson, and today we will be talking about the law of cosines. Objectives are as follows. First, determining if the law of sines or the law of cosines should be used to solve a triangle problem. Second, using the law of cosines to solve various triangle problems. And lastly, using the law of cosines to solve application problems. Here is the law of cosines, and it is as follows. If A, B, and C, and that is capital A, B, and C, if they are the measures of the angles of any triangle, and if lowercase a, b, and c are the lengths of the sides opposite the corresponding angles, then a squared equals b squared plus c squared minus 2bc cosine a, b squared equals a squared plus c squared minus 2ac cosine b, and lastly c squared equals a squared plus b squared minus 2ab cosine c. At this point, pause the video and copy the law of cosine formulas so you will have them at your fingertips whenever they are needed. Notice that the law of cosine formula is given set equal to each side of the triangle. So the law of cosine can be used to find the lengths of sides of a triangle. However, the law of cosines also contains the angles, or precisely the cosine of the angles. So each version of the law of cosine can be solved for the cosine of the angle, and then you may use the inverse function as usual to find the angle measurement. So in short, the law of cosines can be used to find the lengths of sides and the measures of angles. Example. Determining if the law of sines or law of cosines should be used to solve a triangle problem. Well, if we look at this particular problem, you will see that you are given the measure of an angle, angle C, and the length of its opposite side. That is the requirement to use the law of sines. So this particular problem would be solved using the law of sines, which is easier, a little bit shorter than a law of cosines. When you do not have the necessary facts to start solving a triangle using the law of sines, we start with the law of cosines. After applying the law of cosines, usually as you find pieces, in other words, using the law of cosines, you will later be able to use the law of sines as more and more pieces become known. You will continue, as in the previous section, of using the fact that the sum of all angles in a triangle add to 180 degrees to find the measure of the last missing angle. Example. Solve the given triangle, round all measurements to 1 decimal place. By the way, when rounding, you should never round until your final answer. So only the final answer should be rounded to 1 decimal place. Steps within the problem, as you move towards the final answer, should not be round. This minimizes error in your answer. Too much rounding within a problem will cause too much error in the final answer. So with this particular problem, we're given a triangle. We know the measure of one angle. Angle A has a measure of 61 degrees. We also know that the length of side B is 20 units and the length of side C is 30 units. We are not given an angle measurement and the length of its corresponding side. The length of the side opposite angle A we do not know. So we do not have enough to start with the law of sines, so we jump right into the law of cosine. Of course, if we find the length of side A, that side opposite angle A, we would be able to move forward with the problem using the law of sines, which is a little bit shorter. So jumping right in, finding the length of side A, using the version of the law of cosine set equal to side A. When we plug in our B value, C value, and also the measure of angle A, all work is on one side of the equal sign, so you would simplify using the order of operation. Of course, I am aware most students today use scientific or graphing calculators that will perform the order of operation for you. So if you have that type of calculator, you can just plug all this in. But if not, remember the order of operation. PEMDAS, so please excuse my dear Aunt Sally. Square first, then multiply, then addition and subtraction from left to right. After you get an answer for this portion, for the right-hand side of your equation, you want the length of side A, not A squared. So remember to take the square root, round into one decimal place. We get a nice, pretty accurate answer for A, and that is A equals 26.8. And that is rounding the final answer only to one place behind the decimal. Well, we just found that the length of side A is 26 and 8/10. So that has been added to the table of known values. So as in our last lesson, section 7.2, the law of cosines, we can use it to finish the problem. We have an angle and the length of its corresponding side. We can plug in 20 for B, solve for angle B. So of course we cross multiply and divide. When doing so, we find that the sine of B is approximately equal to 0.6527, and then taking the inverse of that, we find that angle B measures 40 and 7/10 degrees. So we have the value of angle B. We were given the value of angle A, so we can add those and subtract from 180 to find that the measure of angle C to finish solving the triangle is 78 and 3/10 degrees. Looking at another example of using the law of cosines to solve a triangle. This time, we are given the measure of all three sides, but we are not given the measure of any angles. So we have to begin by finding the measure of an angle. It doesn't matter which angle you try to find first. As you can see, I went with angle C. So since we are solving for angle C, I need to use the version of the law of cosine that contains the cosine of angle C, that contains angle C, and solve for the cosine of angle C. That means A squared and B squared moves across the equal sign. They both will become negative when they cross the equal sign. And then everything has to be divided by negative 2AB. And when we divide by the negative, that makes A squared positive, B squared positive, and C squared negative. Well, now that the formula is solved for the cosine of C, we plug in the given values for A, B, and C. Use the order operation to simplify. It gives us negative 11 over 24. That is the cosine of C. To go from the cosine of C to the measure of angle C, using your calculator, of course, you just enter the inverse cosine of negative 11 over 24 for final approximated answer, because we are rounding to one place behind the decimal, of 117 and 3/10 degrees. Here you will see the remainder of the problem worked out. You may pause and look at it. This is major review because we have been working with the law of sines for a long time. Looking at an application problem. A tunnel is planned through a mountain to connect points A and B. So here's the tunnel. On two existing roads, and we see the two existing roads actually making an angle. The distance from point B to point C is 5.3 miles. And the distance from point A to point C is 7.4 miles. If the angle between the roads at point C is 28 degrees, what is the distance from point A to point B? Well, we do not have the measure of an angle and its corresponding side. We're asked to find the measure of the corresponding side, side C, the side opposite angle C. So we have to use the law of cosine, set equal to side C. So going ahead and doing so, of course, plugging in the value for A, opposite angle A, that's the side measuring 5.3. Law of cosine says to square it. Plugging in the length of side B, 7.6. Law of cosine says to square it. And then just continuing to plug in A and B and the measure of angle C, which is 28 degrees, in the law of cosine in the correct place. Use the order operation to simplify your radicand, everything under your radical, and then take the square root. When you do so, your final answer is 3 7/10 miles is the length of the tunnel. Please use this video as needed to review and learn the law of cosine and to assist you with completing the assignment on the law of cosine and preparing for the upcoming test.